Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 1 from lesson 4-4 in the SavvasRealize Algebra 2 textbook. In today's video, we are learning how to add rational expressions with like denominators. So that word like here just means the same. So what I want to do is I want us to take a look at elementary school again, just to remember how to add fractions that have like denominators. So when you add fractions together, what you need to do is add together the numerator, which is the top of the fraction, and then leave the bottom of the fraction as that same denominator. So when you add, you don't want to add the denominators together, you just leave it as it is. And if you add together two fractions, sorry, I'm trying to think of an example. Maybe like 1/10 plus 3/10, for example. And you add them together, sometimes you need to reduce the fraction. Like here, the 4 and the 10 are both divisible by 2, so I would divide that 2 out. So when we are adding together expressions with like denominators, we're going to add together the tops. Sometimes we might need to check to factor it to see if we can cancel it out with the denominator, and verify our solution works. So here we go. Example A here, the denominator is x plus 4 for both of these. So my final fraction will have that same denominator. And in the numerator, I'll have x plus 5. And then I want to check and make sure that the top of the fraction and the bottom of the fraction, that there's not anything that would cancel out. And in this case, we're good to go. Now, occasionally, it isn't clear that you have a common denominator. So in this case, for example, it looks like they're different denominators. So what I'm going to do is, for any term that I can, or for any part of the fraction that I can, I'm going to factor it. So up here, down here, I'm going to go ahead and factor out an x. And by doing so, now my denominators are matching. So I'm going to keep that common denominator of x times x plus 3. And then I'm going to add together the numerators. Now when I go to add them, I'm going to go ahead and collect some like terms. So I have a 2x and a 3x, which combine to make a 5x. And I have a positive 1 and a negative 8, which combine to make a negative 7. And then I need to check to make sure that there's not anything that I could cancel out in the numerator and denominator. All right, the top is not factorable. So this could be our final answer. Now understand that depending on where you're being asked the question, sometimes they don't like you leaving it in factored form. So you may need to use the distributive property in order to return it to a unfactored form. However, both of these answers are acceptable. All right, so let's go ahead and try another one. So here for part A, sorry, my cat's losing it in the background. So here for part A, my denominator of 2x plus 3 is the same on both of these. And so I'm just going to go ahead and collect my like terms across the numerator. So here I have a 10x plus a negative 4x. All right, that's 6x. And then here I have a negative 5 and a positive 8, which when I combine turns into a plus 3. Now, I know you might be tempted to see the x plus 3's here and cancel them, but those don't cancel. Remember, you can only cancel out terms that are part of a product. So this is kind of an all or nothing deal. All right, and with this last one, again, the denominator is the same. So I'm going to keep that denominator of x plus 5. And in my numerator, I have an x and a 3x. Together, those make 4x. And then a negative 5 plus a negative 21, which makes a negative 26. So there we have it. That is how you add together rational expressions with like denominators. Until next time.